And then with me is Sean Condon. He works in our team. He just joined ONF about like 6 months ago, yeah, give or take. He was a great contributor to ONOS project before at his previous company. He's also in his spare time, which is something that's amazing to us. And we're going to talk about device configuration in µONOS. The idea is that we want to give a brief overview and motivation on why did we do configuration in µONOS. We started with that. We want to give an overview of the system design and goals, take a look at the core components of the µONOS-config project, take a look at the northbound interface, the southbound interface, the GUI, a brief touch on the model plugins. That is the way we bring in Yang specific to your device, and an overview of an end-to-end workflow, touch on the next steps and how to contribute. So I was very much inspired by a talk from Google. All the team was given a few years ago, but there was a few slides that really caught my attention. They were saying that they had a vision, which was this zero-touch networking, because they saw their network and most networks as a triangle where you have three of these things, which is reliability, scale, and efficiency, but you can never hit all three of those in the existing networks before Google started this effort, and that's their vision. They want to have networks that are both scalable, reliable, but efficient at the same time. They don't want to pick two of three. They want all three of them. And this is something that really started us thinking, how can we do it with the new version of ONOS? Another thing that clearly caught our attention was we need to do zero-touch networking because the 70% of failures of the network, and this is real from a paper published by Google, they say that the 70% of network failures happen during management operation. And why is that? Because the management operation have a high level of complexity, span multiple devices with different network types, different services type, and different device types. So the idea that really fueled the start of µONOS, and especially µONOS-config, is that we want to automate as much as possible the process of configuring the devices in a vendor-independent, neutral way, based on Yang models, that abstracts it as much as possible from the human component, does multi-device, multi-object in the network translations that can be rolled back very easily if something breaks, and can be validated. So this is the architecture of µONOS-config. It starts in the middle with a manager. It exposes on the northbound two set of APIs. It uses Ginemi on the northbound and some admin gRPC interface, which we'll go into more detail later. It enables multi-device configuration transaction. It's model-driven, and Sean will show how you can build your own model plugin and use that model plugin based on the Yang models of your device to shape the configuration store and the UI to show that data and subscribe to the state that your device can give. We have the capability to do rollback to previous point in times. We keep a version history of the many configuration changes that happen in the network. We subscribe to device state when the device connects. We have a flat storage of configuration data in a key value store. And the configuration that get asked to µONOS-config to be deployed on a certain device is validated against the Yang model. Meaning that if you have a device that supports open-config and you come up with a request to set value 1 on interface for an interface that does not exist, or you make a wrong request, onos-config, before even touching the device, but just looking at the Yang model of that device, is going to tell you, no, you cannot do that. Again, as we were seeing in the previous talk, it's all cloud-native architecture and is deployed as one microservice. There are some other core concepts which touch really how we deal with configuration that I will let Sean discuss because he did a lot of this implementation and he knows to the heart of this.
Thanks, Andrea. Hope the microphone is on. Okay, so this is just to discuss, I guess, a simplified view of the core components of the configuration system. So at the top level, you have the network change, which is spanning many devices. It could be all across the network or a portion of your network of devices that you want to configure. Below it, we have what we call the configuration. I wouldn't say a configuration is exactly a device, because the configuration can represent a device that hasn't been yet created, or one that, you know, maybe offline or online, or it maybe was there in the past. Okay, so we keep configuration as a separate thing to a device, but a network change is a collection of changes on configurations. The change itself is what you might call a set of key value pairs, and it's immutable. Okay, once you create this change, you know, it gets a hash, it's immutable, and it may be reused again. You know, so what you might have is you might have an original configuration change with all the keys and values in it, and it might be reusable across a set of configurations. Over on the right-hand side, we have the concept of the model plugin, and what this is basically a representation of your Yang models. So you might compile your Yang files for your particular type of device, and we have a script and a system of building these model plugins that we'd like customers to use. And they end up, they're compiled into Go files, and they're compiled as a shared object library and can be loaded dynamically into ONOS configuration. So there's a great deal of extensibility there with it. And while we were in the area of connecting to the device over GNMI, we also decided to maintain the state of the device in an operational state cache. So what happens there is, once the config system connects to your device, if there is indeed a real device there, it does a get of all of the state. It knows what the state is because it's got the Yang model telling it what the stateful attributes are. Pulls it up, and from that point on does a subscribe on those state attributes, so that, you know, any further changes in states like counters or state getting updated, you know, admin state, op state, and so on like this, are saved in that op state cache. So there's no delay. If you've got a GUI or if you could have, you know, 10 GUIs or CLIs or applications looking for that state, there's no pause while it goes down to the device, and no load imposed on the device by constantly polling that state. Okay. Just to deal a little bit with the northbound interfaces. So all our gRPC interfaces, GNMI obviously is a type of gRPC interface, but we've added two others as well, and they were shown in the previous diagram that Andrea had. Admin is like, you know, administrative things that GNMI doesn't take care of. So like rollback, for instance, or loading model plugins. Diags is a way to look into the heart of it and see the changes and see the configurations and other things like this. And we use those diags to drive CLI and GUI and so on like that, and I'll show that in a little video in a while. So, you know, GNMI itself, it's a well-known interface for configuration management, but really it's built as an interface for managing single devices. And, you know, so we've added on a couple of things onto it using the extension. So we have a couple of well-known sort of extensions. Maybe 100 is the name of the network change I want to make, you know, because a network change can be across many different devices. So this is a way of giving it a name. We can define a version, and we can define a type for that configuration that we want to push down. So that they're well documented in all of our documentation, those extensions. On the southbound side, did you want to talk to this one, Andrea?
I'll talk to it. Thanks, Sean. So basically on the southbound side, again, we have GNMI. It's implemented in the GNMI client, which has the capability to read the capabilities of the device, meaning the Yang models it supports, what type of encoding and decoding it wants. We can set configuration through this GNMI client. We can get the state, but we can also subscribe to the state of the different devices. This GNMI client is the one that populates that operational state cache that Sean was talking about. That operational state cache is driven by the model plugin, and what happens is that after a connection to a device, onos-config gets all the state for read-only attributed to that device and pulls it into that operational state cache, then gets updated to a subscribe. So we subscribe for further changes, and we get the updates and we populate them to the other subsystems in µONOS-config. So a lot of you might ask, okay, you're doing this amazing thing for configuration, but you have only GNMI on the southbound. So that was a specific decision that we took because we wanted to keep the code, as I was saying before, very lean, and it was also very much forward-thinking. So we are betting that GNMI is the future of management interfaces over gRPC that does not only do set and get, but subscribe, which is something that was not really there before. So what about the legacy equipment that is already in the networks? What we plan to do is, in one of those repos that I talked about in the previous talk, we want to have a set of adapters that allow us to connect, for example, the GNMI southbound interface of µONOS to a netconf device. So what that adapter will be is that we will expose GNMI on the northbound to µONOS and have netconf on the southbound to the device. In such a way, we can build one adapter, and that will allow all the netconf devices to be included in µONOS. And that adapter will basically take the GNMI request, split it up into, in this case, netconf, for example. So a get from GNMI perspective will become a get config on the netconf perspective, and then it will give it the XML payload, send it down to the device, get the reply, translate it back, and send it up as a GNMI reply. That can happen in many other protocols. For example, in the future for onos control, that might happen for example an OpenFlow adapter. We also have many types of interactions with µONOS, and you have both web or command line.
Yeah, I can take this one. Really, most of this is probably shown in the video. So basically, we have a rudimentary GUI here for showing, the internal concepts, and basically it was built here for the demo this week. I think probably the best thing to do is move on to the video, Andrea. I think there's you have a way of showing it in VLC. Yeah, so I think it's playing. Yeah, so here we go. First of all, just to show Jordan, I suppose, had shown this, that these are the individual nodes running in the Kubernetes cluster. And what we'll get onto in a minute is what he showed earlier with the onos CLI. So Jordan had previously showed the topo side of it. This is really to show the config side of it. And so all of those internal concepts that I talked about are available. So here we're just going to do onos-config, for instance, get, and it shows us we can do on the net changes, the op state, the plugins, the configs, the changes. So here's an example of my network changes. Okay, so what it is this was a network change. This is the device it affected, and this was the change that was made to that device in this network change. So, a network change could affect multiple devices. Here, I just ran a list of the plugins, and you can see there's 4 models, and it's listing the Yang models that each one of them have. And there's a parallel to all of this in the GUI as well. It's possible to see all of these things. Okay, you can see that was the Stratum one there, and there's quite an array of Yang files associated with it. Here I'm doing a get of the configs. So this is looking at the config, and over time, changes have been added. There's 4 columns of changes, and it wraps around here again. And for instance, I'm going to take this particular change, and I'm just going to do a show of that change. And what it's going to do is allow you to see the path and the value associated with it. Is it playing? Yeah, okay, so here we are. onos-config, get changes. It's going to see the change. And you can see there were 6 different attributes set in this one. You can see that the path is that kind of natural naming that we have, driven by the Yang files, and the capability to handle keys and all of that kind of stuff of lists. And what we've done as well is we've strongly typed the data that we're keeping in the data store, so we store it as a byte array. Here I'm going to show the op state, and what this again is a list of paths and values. And again, Strongly typed, you can see the type is there and the value, so you know we can cope with leaf lists, byte arrays, you know, all of the data types that are possible through Yang. Okay, so I think, yeah, so this was an example of using a tool called GNMI CLI, and so this is a general purpose tool that's available that allows you to send a proto file down to a GNMI northbound interface or even to Stratum itself. Here we're going to send it into onos-config just as an example of a command line tool that you can take this thing at the most basic level. You could also write a GNMI client in Python or Java or any other language you wanted to use because you know the proto files are available and you put it into the proto-C compiler. So this has made a change now. What it's done is made a change that's sending a configuration change down to 2 different devices, and that's like the kind of key of the network changes. You can see here's my last network change, and it's applying to these 2 devices, and because it was the same change was applied to both, you know, the checksum of the change is exactly the same. So this was just to show the GUI that we built. This is like a topo view. But here I have a configuration view, okay, and what it is it's showing a tree of configuration that's modeled by Yang, I guess you could say, with 3 interfaces here, and each one of the interfaces had 3 attributes configured. And it's a layered view showing each of the subsequent configuration changes that were made, so you can go back in time by exploring the history. Also, we have the ability to view the state here. So we're reading this from the operational state cache. And this is just a way of showing the kind of capabilities that are in that op state. You can see the list of counters. What I've turned on here is the read-write paths. And because we're driven by a Yang model, I had 3 attributes configured. There were all these other attributes I could configure as well. So because the thing is driven by Yang, you can have that kind of level of interactivity with it. And also, when you make a configuration change, even through GNMI or the CLI, it can be validated straight away to make sure that you're not sending rubbish down to your network element and you're not going to upset it. This is just a look at the network changes, and here we select this last one that I created, and we can go up and we can roll back on that network change. Many of you that may have seen the demo during the past few days, and you can see that the evidence is there that this is actually rolling back that change and sending the change down to the actual device as well. And finally, I think we're going to look at the model plugins view as well. No, that's it. I think it ended there. Yeah, in any case, the model plugins view was really just a list of them by default. We've created 4, you know, a Stratum one and a couple of test devices where we just built Yang models ourselves to, you know, explore the full extent of Yang with leaf lists and all of the different types of capabilities Yang has. Like I said, you take your Yang, you generate the Go code, you build a shared object library, you can load it into onos-config at the start, and it can validate that your config is valid when it's starting up. You can load it at runtime as well. And like I said, every time you make a network change, it's driving the validation of that network change. And again, it's used in retrieving operational state, for prompting, giving you metadata, and so on like this. And we have a document describing the process of building a model plugin. So I think you were going to handle the workflow, Andrea?
Yes. So the idea is, okay, now this is a wonderful system. What can I do to bring on my device to it? So there's a few steps. First one is that you have to have, for your device, a Yang model that clearly and rightly describes the capability of the device. Because the way we have done the system is that we expect that the Yang model is exactly what the device is capable of. If you give me a Yang model that then the device does not actually support, or that it supports only 1/10 of it, then onos-config will pass configuration for the 9/10 that you don't support, and then your device is going to fail. So there needs to be a Yang model that exactly models the capabilities of the device. And you can do that with deviations. You can pick a standard model, and that's the model that we have done with Stratum. You pick a standard Yang model, and you say, okay, I only support these 10 paths. You deviate from the Yang model, open-config, by saying, open-config deviation Stratum not supported this set of paths. So in that way, onos-config takes it. After you build it, you load it, and that way, onos-config then now knows that when it's binded to a device, thanks to his name, it's actually something that he can leverage to make proper configuration to the device. You can also, before connecting your device, create an initial configuration. We have in onos-config the capability to load the configuration before the device shows up. You just load it for a certain device type, and when the device shows up, you specify that device type for that device, and onos-config automatically, during connection, after the connection is successful, sends down that configuration. So, again, as I was saying, you connect to a device, you link it to the device type and the version of the model. Then, at this point, you have a configured initial configuration on it, you have it connected, and you can configure the parameters on that device. You can view the read and write paths as a guide for new attributes. You can observe and subscribe to the state that was shown on the UI. But also, interesting enough, you can add a new version of the model. Let's say you have an incremental approach to implementing stuff in your device. You can bring in a new version of the model plugin, call it model plugin Stratum 1.1 instead of 1.0. And then you bring in the new software on your device, and it's 1.1 capability, and you load the new model plugin into onos, and then onos-config knows that if it's a 1.1 Stratum, use the 1.1 Yang model. If it's a 1.0 Stratum, use a 1.0 Yang model. So you can also decide to migrate the configuration based on the Yang model and push it again to the device. So what are the next steps? Obviously, this is not a shiny ball that it's perfect and it doesn't require any work. But so at the moment, we have parts of it in a distributed implementation, but we want to complete that distributed implementation based on the Atomics Go clients that Jordan put together. We want to include a device-specific driver mechanism, which is, again, plugin driven, because we recognize that different devices can have different behaviors in terms of like subscription and stuff like that. So we want to include the capability to even do a more fine-grained tuning of how onos-config interacts with the device. We also want to do platform hardening in terms of security, performance, and events handling at scale. On the GUI side, Sean and the team wants to put in a search bar, Google-like search bar, where you put in like, okay, I want the interfaces, and you search for interfaces, and it reconfigures the graph that Sean shown before in a way that it just shows that path that you search for. And we can also include time series data plotting for the state. Packet in, packet out, packet drops, received on a specific interface. Obviously, we need to work more on documentation, and a very important thing is tutorials, because at the moment, this is the first set of talks that was actually given on µONOS, so there's a lot that needs to be done to help developers to get on board. There's a lot there, but there's always more that we can do. You want to add anything?
No, that's it.
Okay,
no, that's
perfect.
Good.
Then, I've shown this before, and I talked this before, but I'm going to say it again. You can join the µONOS Slack channel on Slack. That's our onos project Slack. You can attend the onos TST meetings bi-weekly at Wednesday at 9 Pacific Standard Time. For those of you who are in Europe, that's 6 p.m. You can send a pull request. You can participate in onosdev@onosproject.org, or, and I forgot to say this before, if you have any questions, you can drop an email to anybody in the team that was here before me, and or Andrea at Open Networking, that's me, or Sean at Open Networking, that's Sean. So we have time for questions? One or two questions. Yes?
How do you handle misconfiguration? So let's say someone new come in, they write something without realizing if the value is wrong for them, they're shutting down the network, then the config is sent down, and how in that case how to recover from it? Just curious.
A very good question. Thanks for that. It enables me to go a little bit deeper in a few things. So we provide rollback. There's actually 3 types of rollback. So the first one is this can happen on a single device or multi-device. So 2 of those 3 types we do an automatic rollback. Let's say you send down a configuration which is not valid against the Yang model. onos-config does not even accept it. But you could send down a configuration which is valid for one device, but not valid for the other device. In this case, onos-config accepts the first one, saves it in the store, but checks the second one and says, oh, this is wrong. So what we do is actually we go back and say, okay, this one was valid for the first device, but it was part of a wider network change that we cannot apply, so don't apply it on the device. So that's another one. The other one is that you're actually sending down a valid configuration, but from a Yang model perspective, but for some reason the device refuses it. That is automatically rolled back to the previous state in onos-config, meaning, let's say, for example, let's pick the example of Stratum, okay? Stratum has the capability to handle interfaces at 100G, 40G, or 10G. But from a Yang OpenConfig perspective, it's a valid configuration to send down the speed of 1G. So let's say you do it, onos-config does it, sends it to the device. The device actually replies, no, I cannot do that. So onos-configs roll it back to the previous speed, let's say 40G, and removes that configuration from the list of configuration for that device. The third level of rollback is that something got screwed in the network. All the configuration were valid, but something the network is not working. So at the moment, we don't have an automatic intelligence to pick up the capability, to pick up this network not working state, but we do have the capability to manually roll back that change from UI, CLI. So Sean showed before, you pick a change and you roll it back from the UI. You can do the same thing through CLI. So at the moment, we don't have an automatic feedback loop with the network, but we still do have the capability to automatically roll back a multi-device configuration that botched your network.
And so that rollback is like it's like a stack at the moment. You push new changes on, and then you pop them off as you want to go back in time to the previous configurations.
So in order to maintain consistency, we don't allow you to roll back 4 changes back. So you cannot pick the 4th change in the history and roll it back. You would have to roll back 1, 2, and 3 before you can roll back 4. And that is because we're not looking at just one device, but multi-device configuration. So in a multi-device configuration environment, each device configuration is tied to the other ones. And if you just roll back on one device 4 changes, all the rest of the network can go very badly. So what we do is that you roll back one at a time in a multi-device configuration. We actually do not allow a single device rollback. It needs to be a multi-device. It's done. I mean, the capability is there in ONOS, but it's always tied. If you specify more than one device in your initial network configuration, you must roll them all back because you're bringing your network. Remember, zero-touch networking. You're bringing your network to a previous state. If you send down a configuration for one device, definitely you can roll back just that configuration. But if it's tied to others, you must roll back all of them. Yes.
So probably this is a bit less relevant in an environment where you mostly have OpenConfig compliant devices. But when you have devices that have their own Yang models that are not OpenConfig, then in terms of network-wide configuration and in relation to the service, how that's going to play out. I don't know, maybe that's not actually in the scope of onos-config, it's a higher layer logic, but I don't know, how do you normalize it, if you wish, to a common understanding of a concept?
I think it's a very good question, and you also hit the point in the second part of it. Onos-config at the moment has no intelligence to say this network-wide configuration is correct or not. At the moment, we would probably build an app that enables that. We are Yang agnostic, meaning that a network configuration can happen for multiple devices that have different Yang models. Meaning that, for example, let's pick an optical network, okay? You might have a network-wide configuration to set a wavelength across many devices that can touch an OpenConfig transponder and an open ROADM. That is perfectly fine via onos-config. You can do that. It will get validated on open-config for the open-config device, on open-rodom for the open-rodom device. If the configuration is valid, it will be sent down to the devices. If for some reason whoever was asking that configuration did a mistake and misconfigured the wavelength on one of them, at the moment onos-config does not have the capability to understand that on one of those 4 devices the wavelength was wrong, but we will build an application. Anybody can bring in his set of values, a set of applications that can understand that based on telemetry, based on whatever feedback. Tom, do you have anything to add? Yes.
So this is something that we'll add. It might be a separate application, but most likely it will end up being kind of a hook mechanism inside onos-config, so that's extensible, because it's not just a question of understanding general network coherency, but also be able to enforce certain business policies that may vary from operator to operator. And so the hook mechanism would be, just think of it like a CI for GitHub. Right? Somebody supplies changes to the system, and before the system can apply the changes to the environment, it has to pass a series of checks, kind of integrity check, whether certain configuration changes are going to violate certain business rules or coherency of the network. And if the checks all pass, then we can go ahead, proceed, apply the changes to the environment. So most likely that will be part of the future evolution of the onos-config subsystem, rather than a separate app. You can still build a separate app on it to pre-filter configurations or to issue valid configurations, but some sort of a checking mechanism has to be put in place.